All right. So we have Module 8, Homework 1. We're going to talk about domains and solving rational equations. So we talked about this before. Again, what does that word rational mean? Fraction. Good. So we're just solving equations with fractions in them. Solving rational, which means fraction, equations. So in this section, we're going to find the domain of a rational expression. What does it mean for a domain? What does that mean? What's a domain of a function? The x value. So what can we plug in for x? We're going to understand why the domain restrictions matter. We're going to determine if I can clear or get rid of the denominator, and we're going to solve the equations. So for our first example, it says find the domain of the rational function. F of x equals 7x minus 8 over 9. 7x minus 8 over 9. So we said that the domain of the function is what we can plug in for x. So it's all, now I'm throwing stuff. So it's all possible x values. What can I plug in for x? We said before, it asked us what is a rational function. We said a rational just means fraction. So just a function with a fraction in it. And then lastly, when are rational functions, when are fractions undefined? Yeah, good. So when our denominator remember, denominator means the bottom of our fraction. Is 0. We cannot divide by 0 in our calculator. It'll tell us error, which we know means undefined. So notice that the domain in these problems is written in set notation. Set notation is the set of x with our squiggly brackets, such that x is a real number and x cannot equal whatever. They will have this template for you in my math lab. All you have to do is fill in the blank. This is a blank right here. All you have to do is fill in the blank. So going back to our problem, it says find the domain. So what can I plug in for x for 7x minus 8 over 9? So it's a fraction. When did we say when are fractions undefined? When are fractions undefined? When the denominator equals 0. It's a fraction. So we know the denominator cannot equal 0. Anything else can happen, but we know it's going to be undefined when the denominator equals 0, so the denominator cannot equal 0. It's a fraction, so we know the denominator cannot equal 0. What is our denominator in this case? 7x minus 8 over 9. What's our denominator? 9. So we know that 9 can't equal 0. Will 9 ever equal 0? No. 9 will never equal 0. So no restrictions. So we can plug in any real number for x. We can plug in any real number for x. So going over here to my math lab, I literally copy and pasted this problem into my math lab so that you can see the setup. It says select the correct choice below and then fill in the blank. So if we know that there's no restrictions, which one should it be, A or B? Letter A says a set of x such that x is a real number and x cannot equal blank. B is a set of x such that x is a real number, period. So we know there's no restrictions. So there's nothing that x cannot equal. So it will be answer choice B. No restrictions. So our denominator, which is 9, will never equal 0. So this fraction will never be undefined. So there are no issues. So we can plug in all real numbers, which is B.
You don't have to solve it.
Yep, there's nothing else we have to do. Just find the domain.
There's no x on the bottom, right?
Right, there's no x on the bottom. Questions for me?
What if it was like 9x?
Right. Okay, what if it was like 9x on the bottom? Let's do the next one. It says find the domain of the rational function. We have s of t equals t squared plus 5 all over 5t. It's a fraction, so what cannot happen in a fraction? 0 where? On the bottom. It's a fraction, so our denominator cannot equal 0. What's our denominator? 5t. So 5t cannot equal 0. So 5t cannot equal 0. We're trying to solve for t, get t by itself. How do I do that? Divide by 5. So that way 5 over 5 cancel each other out. We're left with t cannot equal 0. T cannot equal 0. So putting this in set notation. We have the set of x such, I'm sorry, we don't have x's here, we have t's. The set of t's such that t cannot equal 0. This, a bracket, and that's supposed to be a bracket, but I'm not very good at the other brackets. It looks like a cloud. So it's supposed to look, don't laugh at me, I'm trying. I thought that was like one of the things, like when I became a professor, that it would just like click and I know how to draw. No. It's supposed to be this thing. Dang, that is really bad. That one's not bad. And that's the one you asked about? Alright, yeah. Is that better? Yeah. Yeah. My math lab does it for you. Just plug in 0 and you're done. You'd think I'd get better at them doing them so much, but no. I think it gets worse. All right, questions for me? How can I help you? That's it. Just find the domain. X can be any T can be any number. It just can't be 0. Whenever it's 0, that means the bottom's going to be 0. That means our fraction's undefined. Ready for another one? Sure. So find the domain of the rational function. We have f of x equals 6x over 8 minus x. It's a fraction, so what can happen in a fraction? 0 on the bottom. It's a fraction, so our denominator cannot equal 0. What's our denominator? Yeah. You're getting like me, sorry. 8 minus x. So 8 minus x cannot equal 0. Couple options. How would you solve for x here? Subtract 8. So that way 8 minus 8 cancels out, goes to 0. We're left over with negative x cannot equal negative 8. Last but not least, getting x by itself. Divide both sides by -1. We're left over with x cannot equal -8 divided by -1. It's +8. So x cannot equal 8. It can be any other number. It can't be 8. So putting it in set notation. Oh, now I'm like conscious. What's it called? I'm worried about my brackets now. This guy made fun of me. Set of x such that x cannot equal 8. Meh. Not as bad as the cloudy looking one. The set of x such that x cannot equal 8. So it's saying x can be any other number, it just can't be 8.
So the -1 just came to replace the, you know, just cancel them out.
Which one?
Where the -1 comes
This one?
in. Yeah.
Okay, so we're trying to get x by itself, so it's -1 times x. So in order to get rid of it, I can do the opposite. So I did -1 divided by.
Okay.
So that way, -1 divided by -1 cancels out. -8 divided by -1 is +8. Other questions? If not, next page. All right, so last one of the domain. Find the domain of the rational function. We have r of x equals 7 plus 7x all over x cubed plus 5x squared plus 4x. Whew. So it's a fraction, so our denominator cannot be 0. It's a fraction, so we know our denominator cannot be 0. Our denominator in this case is x cubed plus 5x squared plus 4x cannot equal 0. How do I solve this? Factor. What's our first step in factoring? GCF. What's our GCF between x cubed, 5x squared, and 4x? X. Good. So factoring out that x. You have x squared plus 5x plus 4 cannot equal 0. So now factoring x squared plus 5x plus 4. A is 1, B is 5, C is 4. We're looking for two numbers that will multiply together, A times C, to give us 4, and the same two numbers to add together to give us B, which is 5.
4 and 1.
4 and 1, thanks. 4 times 1 is 4. 4 plus 1 is 5. So thankfully, A is 1, so we can go straight to our factors. So what are, for 1, x is a factor, so make sure to bring that down. What are our other two factors?
X plus 4 and x plus 1.
X plus 4 times x plus 1, remember, cannot equal 0. So we have it in factored form. We have it in factored form. How do we solve each one?
Set each one not equal to 0.
Yeah, set each one not equal to 0. So x cannot equal 0. X plus 4 cannot equal 0. X plus 1 cannot equal 0. So we're going to set each factor not equal to 0. So now I can solve each one separately. So x cannot equal 0 is our first one. I'm going to subtract 4 from both sides to solve for x. So we get x cannot equal negative 4. And then lastly, subtracting 1 from both sides on the last factor, we get x cannot equal negative 1. So finally, writing this in set notation, we have the set of x such that x cannot equal 0, negative 4, and negative 1. So that would be our final answer. Thank you. No. Yes, I will. You're welcome. So that'll be our final answer. So I know it's not on here, but once we get questions with this one. So, what if? So what if we had the same exact problem, but our GCF was like 2. So say if we, for example, we had 2 times x plus 4 times x plus 1 not equal to 0. Instead of x, what if we had a GCF of 2? So then we would still set each factor not equal to 0. So 2 can't equal 0, x plus 4 can't equal 0, x plus 1 can't equal 0. So I need to solve for x. If I have 2 cannot equal 0, will 2 ever equal 0? Does that tell me anything about x? No, so I don't even care about this one. So over here, we would subtract 4 from both sides, subtract 1 from both sides. So we would get x cannot equal negative 4, and x cannot equal negative 1. So this domain would be the set of x such that x cannot equal negative 4, and x cannot equal negative 1. So that's the difference whether we have x as our GCF or whether we have 2 as a GCF. Every factor still gets set equal to 0, but we're solving for x.
Is it just 2 or is it any number?
Any number. We're solving for x, and if it's just a number, that doesn't tell me anything about x, so I don't care about it. It will never equal 0. Just wanted to bring that up. Other questions for me? So, if not, these are my favorite of the whole class. So, it's asking us, what's the difference between an equation and an expression? An equation and an expression. So an equation has an equal sign. An expression, no equals. So for an equation we're solving, we're looking for x equals. So for equations we solve. And for expressions we simplify. There's no equal sign, so I can't get x equals in an expression. So for these examples, it says determine whether the following is an equation or an expression. We have x over 2 equals 5x over 4 plus x over 6. Is there an equal sign? Yeah. Yes, so it's an equation or an expression. Equation, done. There's the equal sign. So it's an equation. That's it. My favorite. Yeah. Next one is an equation or an expression. X over x minus 9 plus 8x over x plus 9. Is there an equal sign? No, so expression. Last one. Oh, no, something different.
That's the same thing. It's sort of like writing and
I know. Oh. So, if only the whole test was like that, it'd be good. My job would be easy. But it's not.
multiple choice.
Yeah, exactly. All right, questions for me. So if there's an equal sign, it's an equation. We can solve it. If there's no equal sign and it's an expression, we cannot solve it. Given the following equation, find the LCD. Find the least common denominator. We've done this stuff before. We're just kind of reminded of it. So if we have 6 over z minus 2, of course they put z's and 2's in the same problem, equals z over z squared plus 4 plus z over x plus 2. So for one, let's factor each one and make sure we see what's going on behind the scenes. So we have z minus 2. Can I factor any GCF or anything like that? No, good. So next one, z squared minus 4. GCF, can I factor anything? What? Yeah, what? Difference of two squares, good. So z squared is z times z. One's positive, one's negative. 4 is 2 and 2. And the last one, z plus 2, is already factored for us. There's no GCF, nothing like that. So in the first denominator, we have z minus 2. Second one, we have z plus 2, z minus 2. Third one, we have z minus 2. I'm sorry, z plus 2. So going from left to right. Going from left to right, our LCD. We know z minus 2 has to be there. We know z plus 2 has to be there. Z minus 2 is already there, so I don't have to write it twice. Z plus 2 is already there, so I don't have to write it twice. So our LCD should be z minus 2 times z plus 2. So make sure you read the directions to see what it's asking. And don't just jump in like I try to do.
Supposed to be least common denominator, right?
You're right. My bad. Spell check didn't help me out. In order to have a question.
I didn't realize that it was just that.
Yeah, that's it. Just find the LCD. So make sure you do the directions. Just find the LCD. Just a little refresher because what's coming up next. Other questions? Other questions? Ready? So next one actually says to solve. So the next thing actually says to solve. Solve the equation. So we have 8 over z plus 1/2 equals 6 over z. So notice this function has restrictions in the domain. So first we have to find the domain, see what x cannot equal, and then make sure that our answer works. So before we start solving this, let's find the domain. Same thing that we did in the first part of this section. Find the domain. It's a fraction. So our denominators cannot equal 0. So z is a denominator, so z cannot equal 0. 2 is a denominator, so 2 cannot equal 0. Z is already here, so I don't have to write it twice. So z cannot equal 0. That's already solved for us. So that one's good to go. Then we have 2 cannot equal 0. Does that tell me anything about z? Will 2 ever equal 0? Nope. So don't even care. That one doesn't tell me anything. So I know for this equation, z cannot equal 0. So we're going to go ahead and solve this. In the end, make sure that our answer, it cannot equal 0. So let's try it. So if we have 8 over z plus 1 over 2 equals 6 over z, what do you think? What comes to your mind when you see this? LCD, good. You're right, because most people would be like, ugh, whenever the first thing comes to mind. So thank you for being positive. Yeah, so LCD, what are we going to do with the LCD? Okay, we can make everything the same. My thing is, I really don't like fractions either. I know y'all don't like fractions. So my first thinking is, let's get rid of the fractions as soon as possible, right? Let's go ahead and knock out all the fractions. So what is our LCD? 2z, good. Our LCD is 2z. So what operation is fractions? Adding, subtracting, multiplying, or dividing? Dividing. So in order to get rid of them, we need to do the opposite. So what's the opposite of dividing? Multiply. So if I multiply every single term by the LCD, it will cancel out my fractions for me, and then it'll just be like a normal equation. So let's do that. Let's multiply everything by the LCD. So 2z times our equation of 8 over z plus 1 over 2 equals 6 over z. So multiply each term by the LCD. So we're going to distribute the LCD to each term. We're going to multiply fractions. How do you do so? How do you multiply fractions? Straight across. I have 2z. I wanted to write it as a fraction. What's my denominator? 1. Good. So 2z over 1. So it'll be easier for me to distribute my fractions. So multiplying across, 2z times 8 is 16z. All over 1 times z is z. Plus 2z times 1, 2z. All over 1 times 2 is 2. Equals 2z times 6, 12z. All over 1 times z is z. But you're like, okay, we are doing that to cancel out our fractions, and our fractions didn't cancel yet. We have to simplify. So 16z divided by z. 16, good, our z's cancel. So we're left with 16. Plus 2z divided by 2. Z, our 2's cancel out. Equals 12z divided by z. 12, good, our z's cancel out. We're left with 12. So we're left over with 16 plus z equals 12. So we got rid of our fractions. That's what we wanted to do. If it didn't work, go back and check your work because you did something wrong. So it's kind of like a good stopping, checking yourself point. So we're left over with 16 plus z equals 12. How would we get z by itself? Subtract 16, thank you, from both sides. So those would cancel. We're left over with z equals -4. Okay, here's the part we go back. Is it okay that z equals -4 with our domain?
Yes.
Yes, as long as it's not 0, it's okay. So that's our final answer. Z equals -4, and it works with our domain. Done. So if you want to get them all if you want them to all have a common denominator, you can do it that way too. That's the way my math lab does it. I like to go ahead and get rid of the fractions as soon as possible, so I multiply everything by the LCD, simplify, and then I'm left with one single equation which I can solve out just like normal. Questions for me? What questions do you have for me? If not, let's keep going. We'll take a break in a second, I promise. Solve the equation. We have x plus 2 over x plus 1 equals 1 over x plus 1. First, we have to find the domain. It's a fraction. So we know our denominator cannot equal 0. Our denominator in this case is x plus 1, so x plus 1 cannot equal 0. Solving for x, we're going to subtract 1 from both sides, so x cannot equal -1. X can be anything else, it just cannot be -1. So we're going to leave that right there and come back to it in the very end. So if we have x plus 2 over x plus 1 equals 1 over x plus 1. Again, we want to get rid of the fractions. We do so by multiplying by the LCD. What should our LCD be? X plus 1, good. So we're going to multiply everything by x plus 1. We're going to multiply both terms by x plus 1. Remember, our LCD is x plus 1 over 1, so we are going to distribute that to both terms. Multiplying straight across, we get x plus 1 times x plus 2 all over 1 times x plus 1 equals x plus 1 times 1, which is x plus 1, all over 1 times x plus 1, which is still x plus 1. So basically the LCD went to the tops, the numerators of both equations. What cancels? X plus 1s. What's left over on the left-hand side? X plus 2. What's left over on the right-hand side? 1. Good. X plus 2 equals 1. So we got rid of the fractions. That's what we wanted. So now I can solve this like normal. How do I do so? Subtract 2 from both sides. So we are left over with x equals 1 minus 2, which is -1. Is it okay that x equals -1? No, because x cannot equal -1 was our domain. So no solution. In my math lab, sometimes they write it using this symbol. So 0 with a line through it. So make sure if you write your zeros that way, don't, because that means empty set. That means no solution. Our set of solutions is empty. So there'd be no solutions. So that's why we have to check the domain first. Questions for me? How can I help you? Questions for me? How can I help you? Next page. Solve the equation. 6 over x minus 1 equals 12 over x squared minus 1. So x minus 1 is good. What do you notice about x squared minus 1? X squared minus 1. Difference of two squares, difference of perfect squares. So x squared is x times x. 1 is 1 times 1. 1's positive, 1's negative. So I factored it to kind of really see what's going on in the denominator. So first we have to find the domain. It's a fraction. So our denominator cannot equal 0. Our first denominator is x minus 1. Cannot equal 0. Oh, no, I put parentheses around it. Then we have x plus 1 in the denominator. Cannot equal 0. We already have x minus 1 right here, so I don't have to write it twice. Solving each one separately, I'm going to add 1 to both sides, so I get x cannot equal positive 1. The second one, x plus 1 cannot equal 0, so I'm going to subtract 1 from both sides. And we get x cannot equal negative 1. So our domain says x cannot be positive or negative 1. It could be anything else. It just cannot be positive or negative 1. So that's done. We'll leave it right there. We'll come back to it in the end. So getting rid of our fractions, we need to multiply everything by the LCD. What's our LCD?
X plus 1, x minus 1.
Nice. X plus 1 has to be in there. X minus 1 has to be in there. Over 1. And we're going to multiply that to every single term on both sides of my equation. So 6 over x minus 1 equals 12 times x plus 1, x minus 1. I want to write it in factored form so that way I can see what factors can cancel. So we're going to distribute this LCD to both sides of the equation. So I have 6 times x plus 1 times x minus 1 all over 1 times x minus 1 equals 12 times x plus 1, x minus 1 all over 1 times x plus 1, x minus 1. My favorite part, what factors can cancel? X plus 1, x minus 1, the other x minus 1. So what's left over on top? I can get it. You're good. Thank you, though. 6 times x plus 1 equals 12. So 6 times x plus 1 equals 12. How do you want to solve this thing? Distribute. So we have 6 times x is 6x. 6 times 1 is 6. So 6x plus 6 equals 12. 6x plus 6 equals 12.
Subtract 6 from both sides.
Subtract 6 from both sides. Thank you. We're left over with 6x equals 6. Almost done.
Divide both sides by 6.
Divide both sides by 6. We're left over with x equals
1.
1. Is it okay that x equals 1? No, it doesn't work with our domain. So what does that mean?
No solution.
No solution. No solution. Stick with me, we're almost there. Almost done. How can I help you? Questions for me? How can I help you? Questions for me? Next one, solve the equation 1 over x minus x over 9 equals 0. Our first step is to find the domain. Again, it's a fraction. So we know our denominators cannot equal 0. We have x as a denominator, so x cannot equal 0. 9 is a denominator, so 9 can equal 0. X equals 0 is already solved for us, or x cannot equal 0 is already solved for us. That one's good to go. 9 can equal 0. What does that tell us about x? Nothing. 9 will never equal 0, so that doesn't matter. So we found the domain. X cannot be 0. So now we're just going to leave that right there and come back to it in a second. Let's go ahead and solve this. I want to get rid of my fractions first. So in order to get rid of our fractions, we're going to multiply everything by the LCD. What's our LCD?
9.
9x. Good. X has to be in there. 9 has to be in there. So our LCD will be 9x. We're going to multiply every single term on both sides of our equation by that 9x. Remember, it's like 9x over 1, so whenever we multiply, we're multiplying straight across. Distributing 9x times 1. 9x over 1 times x is x. Minus 9x times x. 9x squared over 1 times 9 is 9. Equals 0 times 9x. Just 0. Just 0. What factors can cancel? X and 9. So we are left over coming up here with 9 minus x squared equals 0. So we got rid of our fraction, so that's good to go. What do you notice about 9 minus x squared? Difference of perfect squares. We're subtracting two numbers that are perfect squares. So what is 9? 3 times 3. 1's positive, 1's negative. What about x squared? X times x. So it's 3 plus x times 3 times x. 3 plus x times 3 minus x equals 0. So now how do I solve this one?
Does it matter what order? Like.
No, it's okay. We can do 3 minus x times 3 plus x.
No, I mean like it can't be x plus 3.
No, because if you were to distribute it back out, it wouldn't give you the same thing.
Okay.
Thank you. Setting both equal to 0, setting both factors equal to 0, and solving. So we have 3 plus x equals 0. We're going to subtract 3 from both sides, and we get x equals negative 3. And then on the second one, we have 3 minus x equals 0. Again, we're subtracting 3 from both sides, so that way 3 minus 3 cancels out. We're left with negative x equals negative 3. Dividing both sides by negative 1. We're left with x equals positive 3. Is it okay that x equals positive 3 based off our domain? Is it okay that equals negative 3? Yep, so our answers are x equals positive 3 and negative 3. They both work with the domain, so we're good to go. Questions, comments, concerns for me? Questions, comments, concerns for me? Now let's do another one. We're almost done with this section. I know it's long. We're almost done. Solve the equation. 4 over a minus 3 plus 3 over a plus 3 equals 5 over a squared minus 9. 5 over a squared minus 9. So our first thing is to find the domain. It's a fraction. So we know our denominators cannot equal 0. So we have a minus 3 cannot equal 0. A plus 3 cannot equal 0. Then we have a squared minus 9. Difference of two squares. So we know a squared is a times a One's positive, one's negative. 9 is 3 times 3. A minus 3 is already here, so I don't have to write it twice. A plus 3 is already here, so I don't have to write it twice, so that's good to go. So solving each one separately. A minus 3 cannot equal 0. We're going to add 3 to both sides, so we get A cannot equal positive 3. Same thing for A plus 3 cannot equal 0. We're going to subtract 3 from both sides, so we get A cannot equal negative 3. So that's our domain. X cannot be positive or negative 3. Be anything else, it just cannot be positive or negative 3.
What
So,
about 0?
it's okay that it's 0. It's okay, as long as it's not positive 3 or negative 3. Those denominators can equal 0. In order to make A minus 3 0, A would have to be 3. In order to make A plus 3 0, A would have to be negative 3. So to make that whole bottom 0. All right, so now that we found the domain, we can actually try to solve this thing and then go back and check the domain. So actually solving this thing, I'm going to multiply everything by our LCD. What should be our LCD? Good. A minus 3 has to be in there. A plus 3 has to be in there. A plus 3 is already here, so I'm going to write it twice. A minus 3 is already there, so I'm going to write it twice. So A minus 3 times A plus 3. We're going to multiply that by everything on both sides of our equation. 4 over A minus 3 plus 3 over A plus 3 equals 5 over A plus 3, A minus 3. Remember, we want to write it in factored form to see what factors can cancel. Our LCD is written over 1. We're going to distribute this. So we have 4 times A minus 3, A plus 3, all over 1 times A minus 3. Plus 3 times A minus 3, A plus 3, all over 1 times A plus 3. Equals, last one, 5 times A minus 3, A plus 3, all over 1 times A plus 3, A minus 3. So you distributed the LCD to everything. Now the best part, what factors cancel? A minus 3, A plus 3, and then both of them, A plus 3 and A minus 3. So we're left over, bringing it up here, we're left over with 4 times A plus 3 plus 3 times A minus 3 equals 5. So now we can just solve this like a normal equation. 4 times A plus 3 times A minus 3 equals 5. What do I do first? Distribute, thank you. So 4 times A will give me 4A. 4 times 3 will give me 12. Distributing again, 3 times A will give me 3A. 3 times negative 3 will give me negative 9. So 4A plus 12 plus 3A minus 9 equals 5. Now what?
Combine like terms.
Combine like terms. Thank you. So 4A plus 3A. 7A. 12 minus 9 plus 3 equals 5. 7A plus 3 equals 5.
Subtract 3 from both sides.
Thank you. Subtract 3 from both sides. So we're left with 7A equals 2.
Divide both sides by 7.
Divide both sides by 7. Whew! Now that we're wore out. A equals 2 over 7. Can 2 over 7 be simplified?
No.
Nope. Is it okay that a equals 2 over 7?
Yes.
Yes, as long as a is not positive or negative 3. This works with the domain. We're done. Let's just finish this section and we'll be good. I know, we're almost done. One more page. How could I help you with this one? How could I help you? I know. How could I help you with this one? How could I help you with this one? I really don't want to do the next one, so that's why. Ooh, two more. So solving 1 over x minus 5 minus 5 over x plus 3. If you're asleep, I'll just try to wake you up. Equals negative 4 over x squared minus 2x minus 15. What's our first step with these? Domain. Our domain. It's a fraction. So our denominator cannot equal 0. So x minus 5 cannot equal 0. X plus 3 cannot equal 0. Then we have x squared minus 2x minus 15. We need to factor this. There's not a GCF. We're looking for two numbers that multiply together to give us negative 15 and add together to give us negative 2. 3 and negative 5. So, hey, how coincidental. We get x minus 5 times x plus 3 whenever we factor it. We already have x minus 5 can't be 0. We already have x minus 3 can't be 0. So we're good to go. Solving each one separately.
Is this supposed to be minus or plus 3? You said minus.
Oh, I'm sorry. Minus 5 plus 3.
Okay, I just wasn't sure.
Do as I write, not as I say, or whatever. I don't know if that's whatever. Thank you for checking me though. So x cannot be positive 5. And x cannot be negative 3. X cannot be a positive 5. X cannot be negative 3. So we found the domain. Now I want to get rid of the fractions. How do I get rid of the fractions? Multiply by the LCD. Good, thanks. So we're going to multiply everything by our LCD. We know x minus 5 has to be in there. We know x plus 3 has to be in there. X minus 5 is already there, so I have to write it twice. X plus 3 is already there, so I have to write it twice. And we know it's over 1. So our LCD is going to be x minus 5 times x plus 3. Multiplying that to both sides of our equation. We want to write it in factored form so that way our factors can cancel. 1 over x minus 5 minus 5 over x plus 3 equals negative 4 over x minus 5 times x plus 3. So we're going to distribute this to every single term on both sides of our equation. We're multiplying fractions, so we're going to multiply straight across. So 1 times x minus 5, x plus 3, all over 1 times x minus 5, minus 5 times x minus 5 times x plus 3, all over x plus 3, equals negative 4 times x minus 5, x plus 3, all over x minus 5, x plus 3. What factors cancel? Bless you. X minus 5, x plus 3, x minus 5, and x plus 3. So we're left over with x plus 3 minus 5 times x minus 5 equals negative 4. So we got rid of the fractions, so that's what we wanted. So now we can solve like usual. What should I do first? Distribute. So we're going to distribute this -5. So we're left with x plus 3 minus 5x plus 25 equals -4. Now what? Combine like terms. Good, thanks. X minus 5x will give us -4x. Thank you. -4x. We also have 3 plus 25. What will that give us?
28.
28. Good, thank you. Equals -4.
Subtract 28.
Subtract 28 from both sides. Thank you for your enthusiasm. So -4x equals -32.
Divide both sides by -4.
Divide both sides by -4. We are left with x equals 8. Is it okay that x equals 8 based off our domain?
Yes.
Yes, it's okay. Boom, we're done with that one. Last one. Last one. Last one. How can I help you? Questions for me? Questions for me? Last one. Last one. So 1 over x minus 2 minus 2 over x squared minus 2x equals 3. So I need to find the domain. We need to find the domain. Again, it's a fraction. So again, the denominator cannot be 0. It's a fraction, so the denominator cannot be 0. So x minus 2 can't be 0. Then I have x squared minus 2x. Can I factor this? Is there a GCF?
X.
X. Taken out of x, what's left over?
X minus 2.
X minus 2, good, thanks. So x minus 2 can't be 0. This x cannot be 0. X minus 2 is already there, so I don't have to write it twice. So solving each one, we get x cannot equal positive 2, and x cannot equal 0. It could be anything else, it just cannot be positive 2 or 0. So our domain's done. We'll come back to that in the end. We have 1 over x minus 2 minus 2 over x times x minus 2 equals 3. I want to get rid of the fractions. How do we get rid of fractions? Multiply everything by the LCD. Thank you. So what should our LCD be in this case? Perfect. X times x minus 2 over 1. X minus 2 is there, x is there, and x minus 2, we said, was already there. So we're multiplying that to every single thing on both sides of our equation. 1 over x minus 2 minus 2 over x times x minus 2 equals 3. So x times x minus 2 times 1, which is x times x minus 2 all over 1 times x minus 2, minus 2 times x minus 2 all over x times x minus 2 equals 3 times x minus 2 over 1. My favorite part, what cancels? All that stuff. X minus 2's cancel, x's cancel. We're left over with x minus 2 equals 3x times x minus 2. So we got rid of our fractions. We're good to go. We can distribute. So we have x minus 2 equals 3x times x is 3x squared. 3x times negative 2 is negative 6x.
Did you divide that by x minus 2 each side?
We can't divide, but you're close. I see that there's x's and stuff on both sides, so let's combine like terms. So let's subtract our x over here. I'm also going to add my 2 to both sides while I'm at it, because I'm running out of space. To get everything on one side. I notice it's a quadratic, ax squared plus bx plus c. So that means in order to solve them, we have to get it in standard form. So we have to get it set equal to 0. So we moved everything on the right-hand side, so we have 0 equals 3x squared minus 7x plus 2. So it's a quadratic in standard form, it's set equal to 0. So that means we have to factor. There's no GCF. Our A value is 3. B is negative 7. C is 2. We're looking for two numbers that will multiply together to give us A times C. So 3 times 2, which is 6. And the same two numbers that add together to give me B, which is negative 7.
Negative 6 and negative 1.
Thank you, negative 6 and negative 1. Negative 1 times negative 6 is positive 6. Negative 1 times negative 6 is negative 7. Unfortunately, A is 3, A is not 1, so we have to factor by grouping. So we have 3x squared. Instead of negative 7x, we're going to split up negative 7x using the numbers in our blanks. So negative 1x minus 6x plus 2 equals 0. So now I can group the first two and I can group the last two. Group the first two, group the last two. Coming up top. So bringing it up top, I'm just going to rewrite it so that way I can see it better. So 3x squared minus x minus 6x plus 2 equals 0. Looking at our first two terms, GCF. X, factoring out of x, what's left over? 3x minus 1. Looking at our next two terms, GCF. I want 3x minus 1 to be left over. Negative 2. Factoring or dividing out negative 2, what's left over? 3x minus 1. We know we did it right because they are both 3x minus 1, so that'll be one factor. Our other factor will be x minus 2. So we have 3x minus 1 times x minus 2 equals 0. Setting each factor equal to 0. And solving each one separately. 3x minus 1 equals 0, so we're going to add 1 to both sides. 3x equals 1. Divide by 3. So x equals 1/3. And then over here we're going to add 2 to both sides, so we get x equals 2. Based off of our domain, is it okay that x equals 1/3? Yes, so that's our answer. Is it okay that x equals 2? No, so this one does not work. So our only answer is x equals 1/3. So that was our Module 8 Homework 1 notes.